Okay, this is the third question in our min-max workshop, and here we go. Let's try it. This one has a rain gauge that's in the shape of a cone, and the water flows into the gauge, okay? The height of the water is 8 centimeters, okay? That's how much this is filled up to. The angle between the cone edge and the radius is 60 degrees, right there, like it is in the picture, okay? Now, here's some formulae you might use. The volume for a cylinder, the volume for a cone. This is a volume for a sphere. Well, this is a cone. We probably are going to use this one right here, the formula for the volume of a cone. Okay, 1/3 pi r squared times the height. Okay. Now, the first question, they lead you around a little bit in this question. They say determine R in terms of H and leave your answer in insert form. Well, let's just take a look at how they did this. Well, we've got to use some trigonometry. We know that if they gave us this 60 degrees, opposite over adjacent is H over R. That's the tangent of 60 degrees. Well, the tangent of 60 degrees, your calculator will tell you, is √3. Well, what we need to do, since we are going to try and figure out what the radius is, this radius and this tangent of 60 degrees, the way the arithmetic works is you divide by tan 60 and you multiply by r. These guys can trade places. Hey, we've got a formula for r for the radius. And what it equals is h divided by the tan of 60. Your calculator will tell you it's √3. So there's the radius expressed in terms of h, and we'll leave it in insert form. Why not? Okay, well, now we need a formula. The next question says, determine the derivative of the volume of the water with respect to h when h is equal to 9 centimeters. Well, first we've got to get the volume of the cone. So here's what they did is instead of h, we've got a way for doing h. Now it's h over √3. That the radius is really h over √3. So we can rub out the r and put h over √3. When we square it, it becomes h squared. This √3 becomes just 3. Times 3 gives me 9. The h squared times h is h cubed. Okay, well, there's our formula for the volume. Now we're looking for maxes and mins and all that kind of stuff. We take the derivative, and we just go 3 times the 9th is 1/3 pi r h squared. We just subtract 1. Just do the derivative thing to this. Hey, but they're not asking for a max and a min. They actually ask for, let's see what they ask for. Determine the derivative of the volume of water with respect to h if h equals 9 centimeters. So they're saying put 9 centimeters in for h. Okay, and so we do that. We go 9 squared is 81, and 1/3 of 81 is 27. 27 pi, or 85.82 cubic centimeters. That's the volume, because it's volume, it's cubic centimeters. So they are actually asking for the value of the derivative when h equals 9. They didn't ask for a max or min, so you do what they say and just put 9 into the derivative formula. And that's it for our third question. That's what we're doing. That's how it works. That's it. That's the third question in this min-max calculus workshop. And hopefully, this helps. Okay.